what's typically what we like to check first? 1 and -1, because those are usually the easiest. That's still going to be in effect. 1 and -1 are always going to be possible rational zeros. So if we're using number 64, we know that possible zeros will always be 1 or 0. And so typically we start by checking 1. When we do 1, we get 3, 4, -21, -10, 24. Okay, and so we end up with 3, multiply gives us 3, add is 7, multiply, add, multiply, add, multiply, add. Okay, so in this case, awesome, it worked. Okay, the shortcut the book will kind of talk about is what we start to notice this pattern as is when you do 1, all you're doing is adding the coefficients across, because that's really what's happening. I've got 3 plus 4, which is 7, plus -21, which is -14, plus -10, which is -24, plus 24 gives me the 0. So really what you're doing is just adding your coefficients. So when you see what the book's talking about as far as using that shortcut with 1, all they're doing is they'll add the coefficients. And so if it makes more sense, go ahead and do it in synthetic division. To a certain degree, you want to use synthetic division because you need to know what this remaining amount is if you find a perfect factor like we just did anyways. Okay, so that's a good one to check. -1 is always another good one to check. So again, once you find a factor, use the remaining amount because we want to continue to factor it down. So if I use -1, I end up with 3, -3, 4, -4, -18, +18, and -6. Okay, so that one did not work. Okay, so we don't have a 0 there. And the trick for -1 is you'll notice that if I plugged in -1 everywhere, even exponents, it stays the same sign. Odd exponents, it would flip-flop the signs. So we add the exponents, but we flip all the odd, we add all the coefficients, but you flip the sign of all the odd exponent ones, the odd degree terms. So it would be 3 -4 -21 +10 +24. That's that trick they'll show you. Otherwise, again, just use synthetic division. It's fine. So in this case, that one doesn't work, but we did at least find the factor x minus 1 came out of this deal. Okay, and we're left with this 3x cubed plus 7x squared minus 14x minus 24. Where do we go from here? This is where some of our tricks will help us. So the first one is going to be looking at sign changes, and this is what Descartes' rule is. Descartes' rule is going to say if I look at the sign changes, I go positive, positive, so there's no sign change, to negative, so there's one sign change, to negative, no sign change, back to positive. So I change signs twice throughout that. That's going to tell me that I have 2 positive zeros. Okay? So when I'm looking at it with x equals 1, okay, I have 2 positive zeros or an even number less. Okay? And I'll explain why they say or an even number less. I could have 2 positive zeros, or if there exists a complex 0, because they have to come in pairs, you're going to have 2 less. So I could have 2 or 0. If I had 3, I could have 3 or 1. Does that kind of make sense? So you either have these zeros or complex zeros come in pairs, so that kind of pulls out pairs of them. So anyways, this allows me to know that I've got 2 positive zeros. How many total zeros are in this function? 4, because it's a 4th degree. So how many do you think are going to be negative? 2 of them. Okay? Now, I think that's the easier way about finding this, is that the remaining amount are going to be potential negative zeros. Okay, so same situation here. It's going to be 2 or 0, because we could have an even number less. The way the book will have you do it is it'll actually have you flip the signs of all these. So this becomes negative because it's an odd exponent. This becomes positive because it's an odd exponent. And so now we count the sign changes. So there's one sign change there. The negative stays the same. The positive is my second sign change. the positive stays the same. So I would do the same Descartes rule, but I would do it with -1 and count the sign changes. Otherwise, I think once you find the positives, just take it away from the total possible to find your negatives. Whichever one makes most sense to you, go ahead and use that. So now I know how many positive and negative zeros there could be. I found one positive zero, so I know there must exist a second one. So we can go try to find that. What number should we guess? Anything that is going to work has to be, and the book is going to identify this as P, which is your constant term, and Q, which is your lead coefficient. Your possible zeros have to be factors of P divided by Q. So what that means is my P value is 24. 1, 2, 3, 4, 6, 8, 12, and 24. Okay? So now instead of any number in the world being a possibility, I've reduced it down to these factors divided by what my Q value is, which because my Q is 3, the only two factors I have are 1 and 3. And so essentially what ends up happening is you end up with all of these divided by 1, which is just those numbers. So my possible zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. And then if I divide them all by 3, 1/3, 2/3, 3/3 is the same as 1, so you don't need to list that. 4/3, 6/3 is the same as 2, and 8/3, 12/3 is 4, 28/3 is 8. So the only ones we need to add to this list are going to be plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. What you just created is a total list of any possible rational zero for this function. Has to be one of those values. So now you have educated guesses to help you go forwards. Okay? So based on this, we would probably naturally want to pick 2. But if it wasn't divisible by 2, let's say it was an odd number out here, you would know I should not go to 2. I should just skip straight to whatever the next multiple is. In this case, we'll go to 2. So if we try 2, we'll see what we're left with here, which is the 3, 7, negative 14, negative 24. We'll work through this piece. So if 3 comes straight down, this will be 6, 13, 26, 12, and 24. Sweet, that one worked. Okay. So that one is going to work again for us, which is nice. So x minus 2 is a factor. And then we're left with a quadratic. Okay, another thing that I'm going to point out, and this will tell you when you can stop going up. There's 2 things that just told us we can stop. One, I just found my second positive zero. There is not going to be any other positive zeros. I don't have to go check 3, 4, 6, 8, 12, or 24, or any of these thirds, these fractions. I can say, okay, I found my 2 positive zeros. The other 2 must be negative. We'll go check the negative 3, 4, all those ones. Okay? The other thing that'll tell me, I found my upper bound. When you're checking for positive zeros, as soon as this line on the bottom becomes all positive or 0, you've reached your positive limit. Because all the numbers are just going to continue to get bigger and bigger and bigger from there. You're just taking off towards the infinity. Okay? So this is one of those little side tricks. This will tell you that you've reached your upper limit. Okay? So now I have those, and then the last piece is I can take this remaining quadratic, which is 3x squared plus 13x plus 12, and I can factor that. So my AC here is 36. What's going to multiply to 36 but add to 13? Positive 9 and a positive 4. So we're going to split that apart. So we end up with 3 x squared plus 9x plus 4x plus 12. So that little imaginary wall, factor the left and right side. So we end up with 3x times x plus 3. We can pull out a positive 4. We're left with x plus 3. So our two factors here are going to be x plus 3 and then 3x plus 4. So now I have all 4 linear factors, and I can find all 4 zeros. So if I needed to give my final answer, we could say that x is going to equal 1, 2, negative 3. And then this one, if we set that equal to 0, we'd subtract 4 and divide by 3, so it gives us negative 4/3. Okay, and what we'll notice is all of those were in our possible zeros. So we ended up with 1, 2, negative 3, and negative 4/3. So those all fit inside of our possible zeros. Okay? That's one problem we were able to guess correctly 2 out of 3 times. Okay, so some of these are going to take like a full page to go through if you're not really good at guessing. Okay? And so I'll show you another one that's a little bit more complicated. The good news is I only gave you 10 problems for a block day.
So it's only going to take 10 pages.
Should only take you 10 pages. Maybe 6. Maybe 6. So, all right. So number 72. This one's missing some stuff. So the biggest thing you need to remember, how many x to the fourths do we have? 0. How many x to the thirds do we have? 0. So again, checking for 1 is usually a good starting spot. I've got 1, 0 x to the fourth, 0 x to the thirds, 2x squared, negative 9x plus 6. Okay, using synthetic division, we'll bring this down as 1, 1, 1, 1, 1, 1, 3, 3, negative 6, negative 6, 0. Hey! The ones that have a 1 or negative 1 will be much nicer for you. I will tell you, I think there's at least 1 or 2 that don't. So it makes the guessing game go a little bit longer. But so here we found our first factor. I'm going to take a look at this and say I've got positive to positive, positive to negative. So there's 1 sign change. Negative to positive, there's 2 sign changes. So I have 2 positive zeros. So how many negative ones do I have? How many negative zeros will we have? 3. Good, Candace. 3. Why was it 3, Candace?
Because 5 minus 2 is 3.
Excellent. A 5th degree polynomial will have 5 zeros. If 2 of them are positive, 3 of them will be negative. And again, it could be an even number less. So it's 2 or 0 positive, and it would be 3 or 1 negatives. What you'll see is you're going to have some complex zeros pop up out of this every once in a while. All right, so I've got 1 more positive I could go find, or there's 3 possible negatives. I usually like going where there's more possibilities because you're more likely to guess correctly. Okay, so obviously negative 1 is a good start, a next good line to go with. So we're going to go that direction. So we'll bring that straight down. We'll have 1, negative 1, 0, 0, 1, negative 1, 2, negative 2, negative 8. Okay, so that did not work. Where should we go next?
Negative 8. 2.
Let's go to negative 2. I like that idea. Okay? So if I go to negative 2, is negative 2 even a possibility? How do we know? It's a factor of 6. It works. Okay? So my possible factors this time, there's a whole lot less possible zeros out of here. Factors of 6 are 1, 2, 3, and 6. Factors of 1 are just 1. So the only possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. If it's a rational zero. So we're going to try negative 2. When I go there, we've got 1, 1, 1, 3, negative 6. Bring that down. 1, negative 2, negative 1, positive 2, 3, negative 3, 0, 0, negative 6. Bummer, negative 2 didn't work. What should we try next? Let's try negative 3. Negative 3. Okay, so when we try negative 3, we've got 1, 1, 1, 3, negative 6. Bring that straight down, that's a negative 6. So 1, negative 3, negative 2, positive 6, 7, negative 21, negative 18, positive 54, 48. Wow, that one's way off. Okay, should I go check negative 6? No, okay? This is the lower bound. The lower bound, when you're checking negative numbers, tells you that positive, negative, positive, negative, positive, or alternating signs, that's your limit. That's your lower bound. So I'm not going to be able, I don't have to check 6. So what should I try? We can try positives. Okay, so we can go try positive 2. Should I redo my negative 2? Did I screw it up? Oh, you're right. That's a negative 6. I did screw that up. Okay, perfect. Thank you. Let me show that error. That should be negative 6, which makes this positive 3, which then times negative 2 makes this negative 6, or positive 6, right? Which then creates that into a 0. Perfect. Thank you. Screwed that one up. Okay. So x minus 2, x equals negative 2 is a 0, so x plus 2 becomes one of our factors. Okay. Good catch. Thank you. Excellent. Nonetheless, negative 3 does represent a lower bound, so we don't have to go any further that direction. So let's go towards the positive. So we have 2 zeros now. We have x equals 1 and x equals negative 2. We go check 2. Let's see if this one works. What are we left with now? We have 1, negative 1, 3, 3, right? That's what we got down here after I fixed it. Or after Chris fixed me. Thank you. So 1, 2, 1, 2, 5, 10, 13. Bummer. Okay? Did I do that one right? I think that one worked. For where? Down here? Oh, which would screw up everything I just did, huh? So 3 plus negative 6 gives us negative 3, which gives us positive 6. Which gives this a negative 3, which makes this 7. Okay, so with that, now that we made those small adjustments, okay, What does number 2 tell me about? When I checked x plus 2, it's all positive, so I've reached my maximum. Good. Okay, so I don't need to check 3, I don't need to check 6. But it's telling me there's another positive 0. What must that other positive 0 be? More than likely. What's the positive number that worked for us? It can't be 3 or 6 since we found the upper bound. What worked for us already? 1. So do you think there might be multiplicity? There might be multiplicity. Okay, so we try 1 again. With this, with it 1, -1, 3, and -3. Okay, just by looking at that, I know it's going to work, right? Because I just added across. I think I'm sure.
Okay.
Double check my math on this one, though. It's early in the morning. So 1 times 1 is 1. Add that would be 0. So 0 is 3 times 1. Add it is 0. Hey, that one worked for us. We did that with good math and good previous steps. Okay, so we found that we have x plus 2. We found an x minus 1 up here. We found a second x minus 1 down here. And now what's left is our quadratic. X squared plus 3. What's going to happen when we have something that's an x squared plus? What are my zeros for that function? Real or imaginary? Why are they imaginary? Because if I solve for this as a 0, x squared plus 3 equals 0. You'd end up with x squared equals -3. So as we take the square root of both sides, x is going to equal plus or minus the square root of 3 times I, or I root 3. So as we're looking for all the zeros then, there's 2 of them. 1 happens twice and -2 happens once. So all of our x values, x is going to equal 1 with multiplicity of 2. We don't have to recognize that yet, but when we're graphing we would. -2, and then we have plus or minus I root 3. Okay, so there's all of our zeros. So some of this gets complex. We got some guessing, we've got some multiplicity stuff. Simple little arithmetic errors can totally throw you for a loop for a little bit. So make sure you go back and check that stuff. But as a whole, that's what we're working on today.